students. So today we have a question from crystal field theory. The question says, draw the crystal field splitting diagram of FeH2O3+. So how to proceed this kind of questions? So here what we need to do, there are a few steps we need to follow. The first step, step 1, what we need to find out? We need to find out the oxidation state of iron. Okay, and how to do it? So let's say we have this Fe H2O6 3 plus, and let's consider this to be X. Now this X plus water, we know it is a neutral ligand, so 6 into 0 is equal to 3. Therefore we can conclude X is plus 3. So here first thing is the iron is in plus 3 state. This is our step 1. Step 2, what we do? We find out the general electronic configuration of the central metal. Here the central metal is Fe3. So what we know? We already know iron, the atomic number is 26, hence it is argon 4s2 3d6, right? Therefore if we have Fe3 plus, of course 3 electrons were removed, so the configuration becomes argon 3d5. So now the given example FeH2O6 3 plus, we have a central metal iron 3 plus, and we know the electronic configuration of the iron, that is 3d5. Now this complex we can easily understand, this is Ml6 type, one metal bonded with 6 ligands, or we could say this is octahedral. Now in octahedral geometry we know, if we try to draw the splitting diagram, so this is our energy axis. These are the d orbitals of Fe3 plus. 5 electrons are there. And now in octahedral field, it will split into T2G and Eg. This is our delta O. This is our barycenter. Now we have in total 5 electrons. These electrons now they will move into T2G or Eg. Here we have a step 3. The step 3 says you consider the type of ligand. What type of ligand is there? By type, what we mean? We mean whether the ligand it is a strong field or a weak field ligand. Strong or weak field. Now in the given example, we have H2O. We know H2O is a weak field ligand. And the criteria is already known to us. If we have a weak field ligand, we know the condition is delta O, crystal field splitting, is less than pairing energy. This is a very important thing we need to understand. So whenever we have a weak field ligand, the condition is delta O is less than pairing energy. If we have a strong field ligand, delta O is more than our pairing energy. Now in this case H2O, it is a weak field ligand, hence this is our conclusion. Now if delta O is less than pairing energy, what we know? The first electron it will move into T2G. The second electron it will move into T2G. The third electron also moves into T2G. Now comes the criteria. As delta O is less than pairing energy, therefore electrons do not pair up into T2G. Rather, they will move into Eg orbitals. So we have this. Therefore, the electronic configuration finally becomes T2G3 Eg2, and this is our crystal field splitting diagram for the given complex. Here again we need to add few things. This is your minus 0.4 delta O, and this is plus 0.6 delta O. So this is our crystal field splitting diagram for FeH2O6 3+. Also remember, this diagram is applicable for any Fe3 bonded to any weak field ligand, right? So this is all about our diagram. Thank you so much.